Hello there, it's Luke, and in this tutorial we're going to be looking at the mechanisms involved in the movement of fluid between different fluid compartments within the body and the formation of tissue fluid. And we're going to be introducing or revising three ideas, which are hydrostatic pressure, oncotic pressure and net filtration. So first of all, we'll just very quickly recap that there are essentially three fluid compartments within the body. There's the fluid that's within cells, the intracellular space. There's the fluid that's within blood vessels, and that we'd refer to that as the intravascular space. And there's the fluid in the space between the cells and the blood vessels, which we refer to as the interstitial space or interstitium. Now, for the purposes of this tutorial, we're going to be focusing on the movement of fluid between the intravascular space and the interstitial space, and specifically in the movement of fluid between the capillaries and the interstitial space. Now, to recap, you may already be aware that fluid will move from an area of high pressure to an area of low pressure. And if we think in terms of our blood vessels, or more specifically our capillaries, the blood will move from an area of high pressure on the arterial side of the capillary blood vessel towards the area of low pressure on the venous side of the blood vessel. So the blood will flow through from the arterial towards the venous side, end of the capillary. Now, you may also be aware that capillaries are permeable to water and also other very small solutes that are dissolved within the water. So it's a sort of semi-permeable membrane, if you like, the capillary itself. And as we've just mentioned, fluid will flow from an area of high pressure to an area of low pressure. And just as that occurs between the arterial and the venous end of the capillary, a similar thing will happen between the higher pressure area within the capillary, mainly at the arterial side, and the lower pressure area in the interstitium. And so we'll have a movement due to this pressure of water or fluid from the intravascular space into the interstitial space. And we refer to this pressure as hydrostatic pressure. Now, as we just sort of slightly laboured the point before, there's greater pressure on the arterial side of the circulation, on the arterial side of the capillary bed. And so that hydrostatic pressure is greater on that side. And as we move along the capillary towards the venous end of the capillary, that hydrostatic pressure will diminish. And you can see that on the arrows on our diagram here. So the hydrostatic pressure is greatest at the arterial side of the capillary. So that's hydrostatic pressure. Now, also within the blood vessel is not just water. There are bigger molecules. There are proteins such as albumin. There are cells. Now, these big molecules and proteins and cells are unable to slip through those small gaps in the wall of the capillary and enter the interstitium, or rather very few of them do in health. And so they remain within the capillary. And what they do from within the capillary, these sort of larger molecules and proteins, they exert sort of osmotic pressure. So they draw water from the interstitial space towards these big proteins and these molecules and these cells within the intravascular space. So from the interstitium into the capillary. And we'd refer to this as oncotic pressure or colloid osmotic pressure. You might see those terms used interchangeably. So there's a drawing of water or fluid from the interstitial space into the intravascular space because these big molecules are unable to leave the capillary, and so they're sucking the water into the blood vessel. And this slide just says the same thing. Now, these two forces are present at the same time. They're acting at the same time. And so you've got hydrostatic pressure forcing fluid out of the capillary, and you've got the oncotic pressure drawing fluid back into the capillary. And we refer to these two things and the sort of balance between them as Starling forces. So hydrostatic pressure and oncotic pressure are the Starling forces, and these are the things that govern the movement of fluid from the intravascular space into the interstitial space and back again. Now, almost all of the water or fluid that is forced out of the capillary through the capillary wall due to hydrostatic pressure is drawn back in by the oncotic pressure. But not quite all of the fluid is sort of reabsorbed back into the capillary, and the fluid that leaves the capillary, leaves the intravascular space, but doesn't return, we would refer to as the net filtration. And in health, running alongside your systemic circulation, so the circulation of blood around your body is the lymphatic circulation, and you have lymphatic capillaries which run alongside the systemic capillaries, and they are also permeable to water, and so the excess fluid, that net filtration, will be drained from the interstitial space into the lymphatic capillaries, and eventually will re-enter the blood supply when those two things join. However, if there's an injury or blockage to that lymphatic capillary network, or say you've had a load of lymph nodes cleared or taken away, sort of tied off or what have you, due to a surgical procedure, that lymphatic drainage is impaired, and you'll get an accumulation of fluid, as we can see in this photograph here of somebody with lymphedema. So this person has had a mastectomy, they've had their breast removed, and as a precaution to stop the spread of any sort of cancerous metastatic cancer cells, the lymph nodes from this region will have been taken away, and so the drainage of the fluid from the arm is impaired, and so you get this edema, this excess of fluid within the tissue in the right arm that you can see here. So, in summary, we've introduced the idea of hydrostatic and oncotic pressure, and we said they're responsible for the movement of fluid between the capillaries and the interstitial space. That collectively they're known as Starling forces, and any change in the balance of those two forces will lead to a sort of greater or lesser amount of fluid within the interstitial space, or we might say that it will influence the net filtration of fluid. And in health, the lymphatic capillaries, one of their jobs is to help draw the fluid out of the interstitial space and eventually have that fluid go back into the systemic circulation. Thank you very much for listening.